Today we're talking about gradients. There's good ones and there's bad ones. But what's the difference between them? They both start at red, they both end at cyan. This one here looks much nicer, and this other one has a grey colour in the middle. But not all gradients look this bad. I just chose these two particular colours to exaggerate the effect. Most will look like these, but they could look like these. With a little extra work, we can make any two colours blend together in this way. So how do we achieve that? First, let's take a look at what's causing the bad looking gradients in the first place. This is the RGB colour wheel. Most of us have already seen this before, and sometimes it's represented as a rectangle. More accurately, however, is the RGB cube. This is because RGB gives us three values, red, green, and blue, which can be plotted in 3 dimensions. Let's ignore alpha for now. The circle we have here is in 2 dimensions, and is just a very squashed cube. It goes from a cube, to a hexagon, to a circle. When we create a gradient, we choose 2 or more colors from this wheel. Let's say you want to go from red to yellow. Visually, color blending is performed over the shortest path between these 2 points. It's linear, a straight line. Mathematically, all this does is take the RGB values of both points and averages them out over whatever distance you want your gradient to cover. In this case, I'm blending the red and yellow over the length of the rectangle you see on the screen. Now, red and yellow isn't too bad. The trouble though is when the distance between the colors gets larger, and the average line between them starts passing through the center area. That's where all the gray tones are, and this is why gradients with complementary colors always look the least pleasing. What you really want to do is get from point A to point B without passing through this center area. The closer we are to the center of the circle, the less saturated and brighter the transition will be. Its values blending with equal amounts of every other color. In graphics software, designers can avoid this center area easily by just plotting a few more points in the gradient. But what about us programmers? How can we procedurally create gradients without them turning into dirt? And please, if the platforms you work on already have this built in, let me know in the comments. I would love to check it out. All right, time to look at some code. Now, if you don't know any Swift, that's okay. The techniques I'm using here can still be applied to any other language. For this exercise, we'll keep it simple and just have a function with an input of 2 colors, returning 3. The extra color being the one that will be used to avoid the center of the color wheel. Avoiding this area is doable in the RGB color space, but it's tricky because you have to work in 3 dimensions. I prefer to keep things simple, so let's stick with the circle. But this means we'll need to switch to a color space that allows us to work in degrees. We can use something like HSB to achieve this. While both saturation and brightness are represented as values between 0 and 100%, hue can be anywhere from 0 to 360 degrees. But in computer terms, all 3 are usually represented as floats ranging between 0 and 1. Now, while saturation and brightness max out at 1, hue can continue wrapping around the circle infinitely. At 0 degrees, you would find red, and the same goes for 360 degrees and 720. This example I'm showing you today has been created in a Swift playground. On the right side is the output that this code generates, which is 3 pairs of gradients. Each group has the same start and end color. However, the first of the 2 is using my interpolation technique. Now, I'm not going to go into the details of the code here because I want to keep this video as accessible to as many people as possible. If you're interested, I've left a link to the playground in the description. One thing I need to point out though is that this method of mine isn't perfect. For example, going from a dark color to a lighter one doesn't work too well. If anyone knows how to solve this, please feel free to create a pull request. Something else worth mentioning is this great online tool that does a far better job with this type of interpolation. Again, links for all of this, along with other information I stumbled upon when making this video, will be in the description. Thank you so much for joining me on this. If you have any questions, put a comment below or reach out to me on Twitter. Until next time.